The last section of this chapter is to find volumes around the x and the y axes, or volumes of rotation. So there's two types here that we're going to be looking at. We're going to be looking at volume around the x-axis, and then we're going to look at volume around the y-axis. If you want to find the volume rotated around the x-axis, we can use this formula here. V for volume equals pi integral between whichever values you're told you want to find the volume between of y squared dx. Now it says y squared, but it will be the equation of y in terms of x, and you will square that whole equation. Now it's also interesting that there is a pi in this formula, because what happens is when you rotate the curve around the x-axis, it's actually making circular movements, and hence we need a pi in there. Let's have a look at example number 1. Find the volume of the solid formed when the curve y is equal to x squared is rotated about the x-axis from x equals 0 to x equals 2. Now, y is equal to x squared is a curve that we're very familiar with, so let's just draw a quick little sketch over here on the side. Sometimes you may get asked to draw a representation of the volume, so that's what we're doing here. So we have x-axis, y-axis, and we're drawing y is equal to x squared, which is a parabola concave up, like so. Now, if we want to take the section from x equals 0, which would be here at the origin, to x equals 2, so let's say x equals 2 is here, to rotate that around the axes, we're going to draw circles coming all the way down like this, because the curve could get rotated around and we would be making a, not really a cone because the sides are sloping, but kind of that kind of shape around there. So what's happening is this curve is coming around the x-axis like that. So you can put some little arrows on here to say that it is going around in that little loop. Okay, so if we want to find the volume, we're going to use our formula. V for volume equals pi integral, and we're going to be integrating between 0 and 2, and we're integrating the y is equal to x squared, but the formula says y squared. If y is equal to x squared, that means I have x squared for a y, and I need to square that in terms of dx. Okay, let's just expand that bracket. X squared squared would be x to the power of 4. Okay, then we want to integrate. So we're going to leave the pi sitting at the front. We're going to open up some square brackets, and when we integrate, we add 1 to the power and we divide by the power, and put the 0 and the 2 on the ends of that. Then we are going to sub in our values. So we're subbing in when x is equal to 2, we would have 2 to the power of 5 over 5, and then we would subtract, sub in 0, so 0 to the power of 5 over 5. Oh, let's make that a square bracket. So 2 to the power of 5 is equal to 32. The 0 here is not really going to do anything, so we're going to have 32 over 5 from that first fraction, and I'm just going to times the pi into that, so it'd be 32 pi over 5. Now because this is a volume, we're going to write after that units cubed. Okay, let's have a look at the next question. Going to the next page, we're still doing volume obviously, but this time we want to rotate our volume around the y-axis. So the formula changes slightly. We still have the pi because we're making those circular movements. The A and the B will be what we want to find the volume between. But this time we'll want our equation in terms of x. So it'll be x squared dy. So let's have a look at our question. Find the volume of the solid formed when the line y is equal to 2x take away 1 is rotated about the y-axis from y equals 1 to y equals 3. Now we're not asked to draw it, but just since we're new to this, let's have a quick little drawing of what this looks like. So y equals 2x take away 1 is a straight line. The y-intercept would be at -1. The gradient is 2, which means I want to rise 2 and run 1. So this point here would be the point 1, 1. And that would be my line. Now I'm specifically asked to look at the volume from when y is equal to 1 to y is equal to 3. So let's say 3 is up here. So I'm taking that part and that part, and what's going to happen is I am going to be reflecting that around in circles like this, going around the y-axis. Okay, that's red shape there, that's what I'm trying to find the volume of. Okay, let's have a look at our formula. V for volume to the y-axis is going to be equal to pi times the integral between 1 and 3, and it's going to be an x squared dy. But the problem is I don't have an equation for just x, I have an equation for y. So I'm going to have to do some rearranging. Let's do that over here on the side. So if y is equal to 2x take away 1, let's get the 2x by itself. So that would be y plus 1. And then getting the x by itself, I would divide by 2 to have half of y plus 1. Okay, but to put this into my formula, I need to know what x squared is. So that means I'm going to have to square everything on the right of that equation there. So half squared becomes a quarter. And then I need to also square this bracket, so y plus 1 squared. Because I want to integrate this, it may be easier to expand out that bracket. So I'm going to leave the quarter, and I would have y squared plus 2y plus 1, and then expand the quarter in, would be a quarter y squared plus half y and plus a quarter. Okay, so now that I know that, let's come back to our integral. The pi is going to be sitting out the front. I'm integrating between y is 1 and y is 3. My x squared is equal to the quarter y squared plus half y plus a quarter dy. And now I'm ready to integrate. Leave the pi out the front. Open some square brackets. The y squared will become y to the power of 3. I had a quarter there, so it's going to be 4 times 3, which is 12 on the bottom. For the next term, I have a y, so it'll become a y squared over 2, but with the 2 that's already on the bottom, that will become a 4. And the quarter on the end, we'll need to add an extra y to that, so it'll be a y over 4. And that's between 1 and 3. So all I have to do is sub those values into my equation. So let's sub in that y is equal to 3. So 3 to the power of 3 will be 27 over 12, plus 3 squared will be 9 over 4, plus y is 3, so 3 over 4. Okay, then I need to subtract, subbing in the 1. So 1 cubed is 1 over 12, plus 1 squared is 1 over 4, plus 1 over 4. Grab your calculator out and you type all of that in, and The number part of all of that comes out to be 14 over 3, and then we just multiply our pi into that, and it would be units cubed because it's volume. Okay, so that's a fairly straightforward example of a volume going to the x-axis and a volume going to the y-axis, but there is one more page here, which is to do with finding the volume between two curves. So we've got two formulas here. This first formula is talking about finding a volume between two curves that is going to the x-axis, which can probably be indicated by the dx. And the second formula that we have here is volume between two curves if we're going to the y-axis. And again, you could probably see that with the dy, we're talking about the y-axis. So we're going to do, it's one question, but we're going to do a part A where we take the curve and find the volume to the x-axis, and part B will be finding the volume to the y-axis. So our curve is y equals 4 minus x squared, which hopefully you identify as being a parabola. We could draw a little sketch of our parabola over here. The 4 would be the y-intercept. And if we were to factorize that, you would get 2 minus x, 2 plus x, which also hopefully indicates our intercepts would be at x is a positive 2 and negative 2. So here is my parabola. So this curve meets the y-axis at 0, 4. So this is the point A here, which is 0, 4. And the x-axis at 2, 0, we already worked that out. So this is the point B, 2, 0. And C is going to be this one over here at negative 2, 0. Find the volume generated when the region between this curve and the line AB, so I need to draw a line from A to B. So the area that is between those curves is going to be rotated about the x-axis to produce our volume. Okay, so if we're going around the x-axis, that means I want to use my first formula here, which says I want to integrate pi, so integral. The x values of this integral would be that I'm integrating between x is 0 and x equals the 2. They're the x values that you can see on the axis there. So between 0 and 2, and it says to do the upper curve squared minus the lower curve squared. The upper curve means the curve on top is my parabola. It has the equation 4 minus x squared, and I have to square that curve. Then I want to subtract the lower curve, which is not actually a curve, it's a line. Problem is I don't have the equation of that line just yet. I need to work it out. So let's come back over here to find the equation of that line. I could work out the gradient of that line. The gradient is rising 4 and running 2, but in the negative direction, so it has a gradient of negative 2. And I also know that the y-intercept is this 4 here, so that would give me y equals negative 2x plus 4 for the equation of that line. Okay, alright, so that's what I need. Subtracting the equation of my line, negative 2x plus 4, and I need to square that and dot dx. To integrate this, I'm going to try and make it easy for myself by expanding everything out. So, leaving the pi, I'm going to have 16, double the middle will be negative 8x squared plus x to the 4 minus negative 2x squared will be 4x squared double the middle is negative 16x, and then 4 squared is a plus 16. Let's collect up some like terms. So I've got x to the power of 4 minus, let me undo that because that wasn't right. X to the power of 4 is my highest power, so let's start with that one. The next highest power that I have is the x squareds, which would be negative 8 there, and then I need to subtract 4 more, so that would be negative 12 x squared. Then looking at my x terms, I have just this negative 16 in here, but because of the minus at the front, that would become a positive 16x. And lastly, I would look at the 16, the constant 16, and then minus, when I expand it out, 16, they actually disappear. You could do this in more lines, but there's not a lot of space here. So let's just go with that one. Now we want to integrate. Leave the pi at the front. Square bracket. Add 1 to the power, divide by the power. Minus the 12, the x squared will become x cubed, divided by 3, but the 12 and the 3 would actually cancel out, and again I'm trying to save room here, they would cancel out just to become a 4x cubed. The 16x would be 16x squared over 2, but the 16 over 2 would just become an 8. Close the bracket between 0 and 2, and then sub in. Big bracket, sub in the 2. We have 2 to the power of 5 over 5 minus 4 times 2 cubed plus 8 times 2 squared. Close bracket, then we minus, and we want to sub in 0. But if you put 0 into all of those things, you're just going to end up with 0, so it doesn't do anything. Type all of that into your calculator, except for the pi. The number part works out to be 32 over 5, and we just times our pi in there, and that will be units cubed. Okay, same question, but we want to now do that volume to the y-axis. So the volume to the y-axis, the formula up the top, says that we want to have pi times the integral of the right equation squared minus the left equation squared. And now this is all in terms of y. So that means on my integral sign, I need the y values that I'm integrating between. My y values are between 0 and 4. So 0 and 4 goes on here. The right-hand side equation is my parabola. But the equation of my parabola, I need it in terms of y because I'm integrating y here. So the equation is y equals 4 minus x squared. If we get the x squared by itself, so we do a little switch and we get 4 minus y. Now luckily that's already squared. So that would be my right-hand side equation squared. I don't want to square root it and square it again. So that would just be 4 take away y for my right-hand side equation. Then I also need to work out, I need to minus, and then work out my left-hand side equation, which is the equation of my straight line. The equation of my straight line from part A was y equals 4 take away 2x. Let's get the equation in terms of y, which means I want to get the x by itself. So 2x would be equal to 4 minus y, which means x would be equal to, let's divide by 2, and we would get, let's just leave the half at the front, and would have half of 4 minus y. And then I need to, because I need to square the equation, let's do that here, so it's less working out in my integral. I'm going to square the half and get a quarter. And then I'm going to square that bracket, but I'm going to expand that out. So that would be 4 times 4 is 16. Double the middle would be negative 8y, and y times y makes a y squared. Okay, and of course we could times that quarter in. Quarter times 16 is 4. A quarter of 8 would be a negative 2y, and then a quarter of y squared, unfortunately, still has that fraction in it, so quarter y squared. Okay, so my equation, my straight line squared, is 4 minus 2y plus a quarter y squared dy. Okay, now before I integrate it, there's a few like terms in there that I can collect. So the highest power of y that I have is the y squared, but I would need to expand out that minus there. So it's actually a negative a quarter, or I might write that as y squared over 4. Then the y terms, I have got negative 1 here, and then minus minus would be a plus 2y, would make a positive y. And for the constants, I have got 4 minus 4, so they're going to disappear. So that's dot dy. So I'm down to just 2 terms. Now let's integrate. Square brackets. Add 1 to the power. Divide by the power means the 3 needs to come down here and multiply with the 4 to make a 12. The y, add 1 to the power, divide by the power between 0 and 4. Subbing in, we would have negative 4 to the power of 3 over 12 plus 4 squared over 2. Then we want to minus, subbing in 0 is just going to give a 0 again. And calculating the brackets there, we get 8 over 3, and we times the pi in to be units cubed. And that's it. That's how you do volume. So last exercise is 12F.